Hi, my name is Walter Blood. I'm Principal Support Engineer for Focus here at IBI, and today we're going to talk a little bit about what the zIIP can do. The zIIP is designed to offload work. All right. If I move work from a central processor, shown on the screen, and move it over to the zIIP, all of a sudden my CP has extra room. And that's exactly what the zIIP is designed to do. It will provide extra room in that CP to allow you to pick up queued workload and get more work done. This is the central processor, and it's able to do more work as a result of the zIIP. But let's take a look at the zIIP and see exactly how it works. The zIIP is controlled by the dispatcher and the workload manager. The dispatcher basically is the one that actually does the dispatching of the workloads. The workload manager itself is the one that determines which workloads are going to actually go to the zIIP, which ones have priority access. And in the case of competition, when there are more workloads that want to go to the zIIP than ZIIPs, then the workload manager is the one that makes the decision. You actually set up policies to make those decisions so that you make sure that the zIIP-enabled products can get to the zIIP. Products need to be zIIP enabled, and we'll talk about what that means. Products have to have certain characteristics in order to run on the zIIP. ZIIPs may already be on your system. You may already be running them, and they may be functioning there, and your system administrators may already know how to do this. So let's continue. The workload manager and the dispatcher basically are going to be working together with the CPs and the ZIIPs to make sure that the workload that you've got set up is going to get done. Notice that there's a number of things that are sitting here underneath the CP, some things that the CP can do, operating system, TCP/IP, all of the jobs that basically run in the job queue, DB2, focus, utilities, and there's a lot more. Notice that there are some things on the zIIP side that are not allowed to run on the zIIP, all right? And that is any operating system stuff. TCP/IP is not supported on the zIIP. Jobs are not supported on the zIIP. You can run some of DB2, you can run some of focus, and there are some utilities that have been modified to run partially on the zIIP, right? The zIIP basically allows you to offload the work that has been initiated on the central processor, on the CP, and that's the critical point. It has to start on the CP. Now, let's take a little deeper look into what runs there and what doesn't run there, okay? The CP, the central processor, can initiate processors. The zIIP cannot. This is something that cannot happen, and there are very direct consequences to that. Executing workloads, the CP can execute all types of workloads. The zIIP can only execute eligible types of workloads, and there are limitations, and we'll talk about those. The zIIP never incurs CPU charges, and this is a big point behind the chip, behind the zIIP. The CP is always going to incur CPU charges. The zIIP always runs at 100% of the manufacturer's clock speed. The CP may or may not, depending upon your particular model number or depending upon how you've got your system set up in order to run. The zIIP is not allowed to run operating system or TCP/IP. Right? These have to be run only on the CP. The number of chips that you're permitted to have that are zIIP chips used to be limited. All right. On the Z16 is the first one where that limitation, which was two ZIIPs for each CP, has now been almost completely removed. You have to have at least one CP running on your system. The rest can all be ZIIPs. Finally, the CPs are running in what we call TCB mode. TCB mode is task control block mode. The dispatchable units run at the dispatching priority of the address space, and this is controlled by workload manager. They are preemptible. The zip is running in service request block mode. The dispatchable units are running at supervisory priority. They are not preemptible. All right. The workloads that can run on the zip, well, zips are designed to pick up and do CPU intensive stuff. What do we mean by that? Calculations, report formatting, aggregation, screening criteria, layout styling, transaction processing. These are the kinds of things that are good, and these are the kinds of things that can be moved to the zip. Workloads that we can't perform on the CP, I/O. That's a big one. Anytime we have to do I/O, we have to go from the zip back over to the TCB that called us. Now, Focus and WebFocus do buffer records in order to minimize the effect of this. And in some cases, even with the Focus database, our I/O basically is done via track, not via record. Consequently, the amount of I/O that needs to be done and the number of movements from the zip back to the TC and TCB is limited. Anytime you have to call a third-party software, something like SyncSort or third-party subroutine, you're going to have to go back to the TCB in order to do that, and that's because the zip does not execute. All right, it only picks up work from the CP. Now, DB2, big question. We always get this. Can the DB2 engage the zip engine? And the answer is absolutely yes. And WebFocus and Focus can make use of this. Remote DRDA access via TCP as one of the big ways to get in here. And cross LPAR via hypersockets. Star schema with parallel query operations for specific BI workloads. This is enabled. Index workloads from some of the DB2 utilities. Depends upon the number of indexes that you're actually doing and the use of compression. SQL arriving to DB2 as an enclave SRB. It's already set up to run in the zip, and consequently, it will be moved to the zip if the zip is available. XML processing for XML schema validation, SQL AI functions, these new ones that are coming out in the Z16. If they're eligible to run for parallel query child processes, yes, they can be moved and run in the zip itself. Any well-defined workload manager service class and report classes that are set up for DRDA workload will run in the zip, provided the zip is available. So that's what the zip can do. Now, how does it do this? Basically, one of the big things that's required is APF authorization. The supervisory state means that the load modules must be APF authorized. Now, IBI ships all of its load modules that are required for zip as APF authorized. The AC flag is set to 1. Now, this means that all of your load libraries, when you're running either Focus or WebFocus, anything in your step-lib concatenation or your user lib, all of these must be authorized in order to run. If, when running, the operating system detects an unauthorized library, and it does this right as it starts up, the product will start unauthorized. And it'll continue to run, but it's going to be running on the CP. It will not offload the work for it that you want to have offloaded, and it will not potentially save you some money because you're running on a processor that is not incurring CPU charges. So that's what the zip can do. Now next we'll take a look at what the zip can't do.